Hello everybody, this is Group 2. Let me introduce Group 2 members. Firstly, Syamimi Afiqah binti Syaril Muzani, Jasmine Aimi bin Muhammad Amri, Nurul Amira binti Muhammad Riza, Siti Nurhafizah binti Baharum, Nurul Nabilah binti Rosli. Our presentation will start in
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Syamimi Afiqah binti Syaril Muzani. I will explain to you guys for the introduction of the application of integration and also for the question number 4. Application of integration. Application of integration is applied in various fields like mathematics, science, engineering, and etc. We use application of integration to find the area and volume of curved figures. Under this topic, we have the first one is area between curve and the second one is volume of solid. In order for us to find the volume, we can use this method, washer method, and cylindrical shell method. Okay, now let's continue with question 4. Consider the shaded region in the first quadrant in which is bounded by the curve x equal to y minus y cubed and the y-axis as shown in figure 2. Using the washer method, set up the integral to find the volume of the solid obtained by revolving the shaded region about the line x equal to -2. I will say that this is the case 2 and the axis of the revolution will be on the left side, which is x equal to -2. So we don't have the boundaries yet. As you can see here, we don't have the boundaries here. So we need to find the boundaries. We need to substitute x equal to 0 in this function. And then we will get the value of the y, which is y equal to -1, y equal to 0, and y equal to 1. And right here we can see that it says that shaded region is at the first quadrant. So we will exclude the -1. So we will write here. So since this is case 2, all the formula must be in term of y. So volume integrate from c to d pi fy minus k, which is the axis of the revolution, square minus gy minus k to dy. And then we will substitute everything and simplify everything. We will get y minus y cube plus 2 square minus 2 square dy. And then we will expand. We will get y power of 6 minus 2 y power of 4 minus 4y cube plus y square plus 4y plus 4 minus 4. And then we will simplify everything and then we will integrate. We will get this. After we simplify, we will substitute the upper boundaries and lower boundaries, which is the upper boundaries is 1 and the lower boundaries is 0. So when we substitute everything, we will get 113 over 105 minus 0. So the volume of the shaded region is 113 over 105 pi unit cube.
I am Jasmine Aimi and I will explain this next question. For this question, consider the shaded region in the first quadrant which is bounded by the curve x equals to y minus y cubed and the y-axis as shown in the figure. By using the shell method, find the volume of the solid obtained by revolving the shaded region about the line y equals to 1. So the line y equals to 1 is the axis of revolution, which means this falls under case 2, cross-section parallel to x-axis. The axis of revolution, y equals to 1, is on top of the region. Therefore, we use this formula, which is volume equals to an integral from c to d to pi k minus y times fy minus gy dy. In this question, the boundaries are from 0 to 1. K is the axis of revolution, which is y equals to 1. Then, the curve x equals y minus y cubed is fy, while gy is the y-axis, which also can be called as x equals to 0. Therefore, to start, we can bring out 2 pi because it's just a coefficient, and integrate from 0 to 1, 1 minus y times y minus y cubed minus 0, so we can exclude the 0. The next step is to expand the equation. So, from the expansion, we'll have y minus y cubed minus y squared plus y to the power of 4. Then, integrate all the terms from boundary 0 to 1. After the integration, substitute upper bound 1 and also substitute lower bound 0. When we evaluate the upper bound minus the lower bound, we'll get 7 over 60. Then, don't forget to multiply with 2 pi. So, the final answer for this question is 7 over 30 pi unit cube.
This is question 5, 1 Roman. It's from the 5th chapter, Application of Integration, from the subtopic area. In the subtopic, we have 2 cases. Consider the 2 regions. Region A enclosed by the curve y equals to x squared minus 3x and x equals to -1 and x-axis, and region B is enclosed by the curve y equals to x squared minus 3x and the x-axis. So to find the total area of region A and B, if we look at the regions, we're going to need to use case 1 because the region is parallel to y-axis. So step 1, finding area A. Okay, we're going to integrate from -1 to 0. And the function on top is the curve and the bottom is the x-axis, which is y equals to 0. Then we're going to simplify everything. Then we're going to integrate the function, don't forget the limits. Then substitute the upper boundary and the lower boundary. Evaluate the substitution, gonna get 0 minus with -11 over 6 equals to 11 over 6. Moving on to step 2, finding area B. We're going to integrate region B from 0 to 3. The function on top is the x-axis and the bottom is the curve y equals to x squared minus 3x. Then simplify everything. We're gonna integrate, then substitute the boundaries 3 and 0. We're gonna get 9 over 2. Okay, the last step is step 3 to total out both area A and area B. Area A is 11 over 6 and area B is 9 over 2. Adding that, gonna get 19 over 3 unit squared, and that's the final answer for question 5, 1 Roman.
Hi, my name is Siti Nurhafizah and today I will explain about question 5, 2 Roman. Consider the 2 regions where region A enclosed by the curve y equal to x squared minus 3x, x equal to -1, and x-axis, and region B enclosed by the curve y equal to x squared minus 3x and x-axis as shown in figure 2. Find the volume of the solid obtained by revolving the region A about the line x equal to -3 using the shell method. So, x equal to -3 is axis of the revolution. That means this equation is related to case 1, cross-section parallel to y-axis. As we can see, the axis of the revolution is on the left. Because of that, we will use this formula, which is volume equal to integrate from A to B 2 pi x minus k fx minus gx dx. The boundaries for this equation is from -1 to 0. K in the formula is referred to the axis of the revolution, which is x equal to -3, and then substitute fx with x squared minus 3x minus -1 dx. Next, simplify this equation, we also expand it. We will get x cubed minus 3x squared plus x plus 3x squared minus 9x plus 3 dx. After that, simplify it again, then integrate the equation. So we will get x power of 4 over 4 minus 8x square over 2 plus 3x. The boundary is from -1 to 0. Now substitute upper boundaries, which is 0, and lower boundaries is -1. Then after the substitution, we will get 0 minus -27 over 4, which is equal to 27 over 4. So finally 27 over 4 multiplied by 2, and the volume of the region A is equal to 27 over 2 per unit cube.
Hi, Assalamualaikum. My name is Nurul Nabilah binti Rosli. I'm going to explain the question 5 through Roman, which is the volume of the solid obtained by revolving the region B about the line y equal to 1 using the washer method. We can see that y equal to x squared minus 3x shifted on the top of the region of revolving y equal to 1, and generate the new formula because it shifted on the top of the region. So integrate from origin to the tree and identify the outer and inner layer. So the curve is x squared minus 3x, and the inner layer is the straight line, which is 1. And expand both fx and gx. So from the expansion, we get x to the power of 4 plus 3x cubed minus x plus 3x cubed plus 9x squared minus 3x minus x squared minus 3x plus 1 dx. Before we integrate, we must simplify. So we get x to the power of 4 plus 6x cubed plus 8x squared minus 7x plus 1 dx. And we proceed with the integration, and we get this. And simplify the integration before substitute. And we substitute the upper bound 3 and lower bound 0. For the 0, I'm just write 0 because the answer will be 0. Therefore, the volume of solid generated is 1068 over 5 pi unit cube.
After solving all of the problems, we can conclude that application of integration is one of the most important part in calculus. It can help us to solve many problems that involve area and also volume by using their own formula. If anybody knows the right step and formula, all of the problem can be solved easily. Thank you everybody for watching our video. That's all from us. Thank you.